Okay, we are live now. Okay, hello everyone, and welcome to yet another exciting live session hosted by AirPlanet. We're thrilled to have you join us today for what promises to be an incredibly insightful and informative session. I'll start with introducing the speaker for today. We are thrilled to have Kiruthika Subramani with us. Kiruthika is an accomplished public speaker, ML enthusiast, and a prolific author, known for her contributions to AI and technical writing. With two books, 196 tech talk shows, and over 100 blogs on GCP to her name, she's a recognized IBM data and AI champion and a Google developer expert. In today's session, part of Summer Analytics Bootcamp by IIT Guwahati, Kirutika will guide us through ML with Scikit-learn. As we know, Scikit-learn is a free and open source Python library that provides a wide range of tools and algorithms for machine learning tasks. The session will cover the basics of machine learning using Scikit-learn with practical examples and advice on advancing your ML knowledge. You will gain a solid understanding of scikit-learn's capabilities and receive guidance on how to exploit more advanced ML topics. Without further ado, let's welcome Kirutika. Kirutika, over to
Thank
you.
you so much, Vaya, for this amazing introduction. So, I'm very much excited to meet you all today. And this is Kiruthika Subramani. So, I'm a Google developer expert for machine learning, as well as author for two books and IBM champion for data and AI. So, today I'll be engaging you on the session that is about Scikit-learn. So, hope you all are getting ready for that. So, let's get started without a further delay. Hope my screen and video is visible to every one of you. So let's get started with the session. So before getting into Scikit-learn, I always want to talk about what is machine learning and AI. So today we are talking a lot of stuff about Gen AI applications, like the AI which is capable of creating new content from the existing content. That is, so we can call this era as AI era, which means generative AI era. So that's quite amazing to work with Gen AI. So today, while we talk about machine learning, in the sense, as we know, in AI we try to automate four things using machines. As I mentioned in all my talks, the four things that we try to mimic with machines are: the first one is learning, and the next one is problem solving, decision making, and reasoning. Yes, these are the four things we are trying to mimic using AI. So that is what we the researchers or all the developers are doing in the industry. So what is machine learning? In the sense, of course, we are trying to mimic the learning, which means we are trying to automate the process of learning in machines. So to do this process, we need someone to support, right? Like always in every movies, more than an hero and heroine, there is a character that makes the movie more interesting. Maybe we call it supportive characters, right? So to make machine learning more supportive, as a supportive partner, in Python we have a library called Scikit-learn. Hope my screen Cascade is visible to you. I always suggest you to use Cascade, because it is very easy for us, because I can able to add any of the things here. Because if you feel boring, I can switch into list and different kind of options, more portable than presentation. I would always love to do using Cascade. Hope it is visible to you all. So without a delay, let's get started with the Scikit-learn again. So what is Scikit-learn? So people, whenever we talk about Scikit-learn, there is always a confusion between two Python libraries. One is SciPy and Scikit-learn. So here I'm not talking about SciPy. You know, SciPy is a package used for managing all the scientific mathematical operations, which means array operations, or doing any advanced mathematical operation like calculating an angle or something else. So we can go for SciPy. This is Scikit-learn, right? So Scikit-learn is, as every one of us know, it is a Python library. So more than that, we know Python is an open source language. So this package is also an open source one. So what does SciPy provide as a supporting character to our main hero, that is machine learning, is it provide all the necessary tools that are required for developing a machine learning model. For instance, let's say today many companies, today many companies are running more hard resources, right, in cloud. you know, right? You know who is the supplier of all the hard resources? So we can call Nvidia, right? Nvidia is supplying all the resources, which means GPUs to the companies, like selling I hope you all seen in the internet, right? Like it is selling all the components for digging. Likewise the same thing for making the machine learning process automated using Python to deploy it more easily, we are going with uh, Scikit-learn. So whenever we want to talk about Scikit-learn, I said the one step, that is it automates or it supports plethora of machine learning tasks, right? Here comes a question. Hey Kritika, first we need to know what is machine learning life cycle. I know people who are watching may be familiar with machine learning, and I know some of the students are joining us, and maybe some of the freshers will be joining us now. So I would like to start with what is machine learning life cycle first of all. So what is machine learning life cycle in the sense? So we are trying to do four important tasks, maybe prediction, classification, clustering, or dimensionality reduction, anomaly detection, or anything else, right? Supervised and unsupervised approaches, anything else, right? So there comes a point that is we need to follow rules to achieve or build the best machine learning model, as like we call it as different types of models are there, like waterfall model, agile model, and DevOps model are there in software development life cycle. Likewise in machine learning we follow a cycle of tasks to achieve it. So let me add here. So the first one is data collection. So I'm typing here, hope it is visible to you. The first one is data collection. So we first collect the data, and then, as you know, another one is after whenever we collect data, there is a problem between data, because data is coming from real world. We can expect the unexpected errors there, so we need to clean the data and process it. So this is the task we do that. And after that, after data pre-processing step, we go for one thing, that is choosing an algorithm for our approach. We choose an algorithm, which means which type of approach or we can use, like choosing an approach. And then we start to build the model. Building a model in the sense, using that algorithm with our data. Before it is called as algorithm, if algorithm is joined with our data, in the sense it is called as model. We start to build model, and the process of training, and then testing we call it as evaluation, that is a perfecting. And after training evaluation, we can go for a deployment. If it performed well in evaluation, in the sense we can go for deployment. And then last but not the least, most of the company people know this. I hope most of you heard that your brothers or sisters or someone working in IT saying this term. That is, I'm working on the monitoring part of the model, right? So it is more important to monitor the model after deployment. So, you know, CI and CD pipelines, continuous integration and deployment pipelines in the DevOps as well as in MLOps. So that is the thing we most ML lifecycle covers. Hope you have a understanding about how an ML lifecycle occurs. If I need to predict a weather of an upcoming week, in the sense I want to follow the streamline of tasks, and you want to know these steps are followed sequentially, not not like a random manner. So you want to get to learn that. So I had mentioned one before term, that is data wrangling. I hope so most of the people will get a question, what is data wrangling, most of the time. So we call it as exploratory data analysis, right? Which means we explore the data to like creating charts. So leaving that exploratory part, if I clean and prepare my data for the further process, in the sense we can call it as data wrangling. So that is what I mentioned there. It is similar to data pre-processing. So hope you got a complete clear view about what is ML and what is machine learning, and what are the steps involved in the life cycle of machine learning. So what's next? So like every time when we discuss only with technical concept, it's never going to work out in machine learning. We need to get our hands dirty, like trying with the stuffs. So let's get started with trying with the stuffs. So, you know, we first, what we do in the sense, we install the package. So I have another one notebook, that is trial IPNB. So I have opened three tabs in my window. Hope you can able to see. One is our mind map, another one is the code. So that I try to develop for you, helping you to understand things, and I'll be sharing you at the end of the session. So no worries. So this is the notebook that helps you to understand things. So let's start with the first step, that is before using any packages. And I want to mention here another one thing, that is I'm using the platform uh, Colab, right? I'm using Colab notebook here. So you can also use it on Jupyter notebook as well. And also in cloud, there is an environment, right? So in cloud, if you're using GCP, in the sense, you can also use Jupyter notebook there. So you can try it there also. So the both has the same steps. So the first step is like before using any packages, what we want to do in the sense, we need to install it. For in the sense, this is one of the command we always use, because it is not a new thing I'm trying to explain you. If you're working with Python, in the sense, you are more familiar with this term, that is pip install, to install that. And this exclamatory mark is used in Colab because it is one of the environmental dependency. So sorry, environmental dependency used here for deployment. So I hope you can understand here what is Scikit-learn. So I am mentioning the name Scikit-learn. Scikit-learn is also called as sklearn. Sklearn, okay. So I'm just installing the package. As you know, Colab environment already has this dependency working on. So it took time because my RAM is uh, getting into that. So as you see here, my requirement has been completed. I did this step. So here you can get why I did this. In the sense, here you can get one thing. I installed Scikit-learn. Have you ever thought why, Kritika, we are getting NumPy, SciPy, JobLib, and Threadpool, everything here? It is showing that they are existing. What is the reason? So here comes one answer for all the questions. That is, the Scikit-learn library is developed from the existing versions, that is NumPy, SciPy, and Threadpool. Maybe we can call it as like saying giving you a book and providing a page number, like a refer page number 12 or refer page number 13. The same wise, all the functions of NumPy, SciPy, and JobLibs together support Scikit-learn. That is the reason it is showing all the dependencies. And if you get a question, hey Kritika, which version of Python are you using? So currently Colab is getting updated with Python 3.10, I hope. So when I started, it was like 3.7. Now it's 3.10. That's amazing. So because it is an open source language, right? So hope you can understand why I'm getting this line and requirement already satisfied and all. So now the first part is completed, which means I have installed my package. You know, already the package is installed on the environment. So the step one is completed. The next step is like we are going to load the data set. So here let me show you what are the steps I'm following. So these are the steps I'm going to follow here for Scikit-learn to build or develop or deploy any machine learning algorithms. We are going to try superficial many machine learning algorithms today. So, and the next step we are going to do is data loading and pre-processing. So data loading and pre-processing itself, it is a two thing, but pre-processing is an emotion. Most of the engineers can understand the term pre-processing is an emotion. Also for me, I worked as a machine learning engineer, so I had an experience of working with pre-processing. It is a quite bit hectic task because I need to have a proper understanding about the data, because the data is from real world, right? So I need to understand the rows and columns according to the company's norms. After understanding that, I need to do the magics and make my data clean. That is always quite interesting task. So let's start with the first step, that is data loading. So what is data loading? In the sense, I have the data anywhere, maybe in internet or maybe in my local storage, everywhere. But that is important. I'm using one separate environment, integrated development environment, that is Colab or Jupyter Notebook or anything, Jupyter Notebook, sorry, or anything. So I need to bring the data into my notebook. So that is what we are doing here. But you know, there are some data sets that are already available in Google Colab environment or loaded into IDEs. So today what we're going to do in the sense, instead of uploading a data from my local environment or from internet, I'm going to use the data which is already available in the IDE environment. So to call a data from IDE environment, we use the command that is load dot. Hope you can understand. So let me help you to understand these terms. So I just add these lines. So whenever I add into new notebook, so that you can understand why I'm adding this and getting this output. So let's get into this line before uploading our data. The first one is import. Whenever we install the package, we need to import it. It is like buying a parcel. After that, we need to open it and in order to use. For instance, if I ordered something from Amazon and I got delivered, if I want to use it, in the sense I want to open the delivered package, like, or else I want to bring it to me and I want to open the package. The same concept here. We want to import sklearn. After importing, as I said you before, scikit-learn is called as sklearn 2. We can also import it as sklearn. We can also install it as sklearn. So and then from sklearn I'm importing data sets. As I said you already, this scikit-learn already have some of the data sets uploaded into it. There are some data sets like penguin data sets, which is one of the famous data sets available in cloud. Likewise, Iris, Titanic data set, house pricing data sets, everything has been manually uploaded, which is already existing in scikit-learn. So what I'm going to do in the sense, I'm going to import data sets from sklearn, because it is like opening my home. Inside a room I have data sets, so I'm just calling it. After that, whenever we work with data sets, in the sense, to perform operations in my data set, which means to rows and columns of data, I need to use pandas, in the sense Python for data analysis. So it helped me to work with to do operations with the tabular data much well. So I'm importing pandas. Hope you are clear why I'm importing all the stuffs. So yes, I got executed it in 2 seconds. It is quite amazing. And the next thing, now let's get into the next thing. As I said you earlier, we are going to load the data set. So I'm going to load the data set. So loading, in the sense, as I said, from the datasets environment, I'm going to load Iris dataset. So let me run it, so that this Iris dataset is brought into my environment now. So I'm ready to use it. I can ready to use it anytime. So now what I did, in the sense, I brought my data into my environment. So the step one is clear, right? So the as I said, built-in data sets, I explained you this part. And the next one is data cleaning. Before that, as I said, we are going to build a machine learning model. So there is two important steps in machine learning. That is, we call it as train test splitting, right? We need to provide a target variable as well as predicting variable or predictor variable to here. So first one is predicting variable. Predicting variable, in the sense, which are the column that helps me to produce output or helps me to guess the output. That is known as predicting variable. And the last one is called target, which is the output. Always, in every time, we have n number of inputs as well as only one output in machine learning. As you know, I'm not mentioning that. I'm not classifying or anything else. I'm just mentioning that there is only one column of output. So that is what we are providing it as a target column. So others as the input or predicting variable columns. Hope you're clear with that. So I'm just providing with data and target, which is a variable already defined to isolate these things. So now I'm just running it. So now everything is assigned. Here comes a question. So here, now you can see here, I'm just printing my data set. Here comes one of the disappointing part. See here, I'm not getting anything in a tabular format. I'm getting all the answers, but it is not in a tabular format. Have you got any guesses why it is happening? Why it is happening? Because why I'm using scikit-learn, I just loaded all the data, and I have uploaded predictor and predicting variable, everything stuffs like target variable or splitting the data sets into further things. And I printed, but it doesn't produce me any tables, or it doesn't produce that CV, which is an CSV file. Iris data set has a CSV, sepal length, petal length, everything, right? It is not produced even in that format. So here you need to understand one thing, that is Iris data set do one thing, that is, I'll show you here. So it doesn't produce a data frame because it is a custom object created by a dataset.load.iris. So every time whenever I upload an object, which means a data, scikit-learn store it as an custom object, right? So it is stored as an object here. So it is also one of the interview questions which has been asked somewhere. So you want to know that in scikit-learn, mostly the data is stored as custom object. After that, we need to use pandas to convert it into a tabular format. For in the sense, I'm doing the next step. So so I'm going to create a data frame. Data frame in the sense creating a tabular format. Now let's do that. You can able to see the difference now. So I'm just doing the steps, like I'm creating a data frame which has columns of features names, feature underscore names. As you know, it carries features. These are one of the functions used there, and another one is target variable, which is y, which is the last column that is classifying them. And now I'm going to print it. Now you can see here the output. It is so amazing, right? So I'm getting the output like the target variable, which means which kind of category it is, right? And the next one is sepal length, sepal width, everything. So I hope you understand some stuffs here. I said you three important things here. When we start to work with scikit-learn, as I said, we need to, if we want to use any packages, in the sense we need to install first. After installing, there is another one step, that is importing, which means I want to bring the package into my IDE, and then I need to import datasets, because I'm not going to upload any dataset from my environment. Instead, I'm going to use the packages which are existing in scikit-learn, because we are discussing here scikit-learn, so I did this. Because I know if you learn pandas, in the sense you know how to upload a data set, that is read underscore csv. For PDF, there is a different version there for what are the steps you want to follow. So for using scikit-learn, I'm using the packages there, and then I just loaded the data set. So, and I given a target and predicting variables, and then I printed, so that I understood that it is stored as custom object, right? Scikit-learn stores the data as custom object. Hope you understand here. And after that, we discussed things, we want to convert it using Python, pandas. So I created a data frame. So now it is clearly visible to every one of us. Hope you understand what I'm trying to say here. So now we completed the two things, that is uploading the data and converting it to our supportable part. And the next comes the term, that is data pre-processing, right? Data pre-processing, in the sense, what is the need of data pre-processing? Let's discuss that first before getting into data pre-processing step. So data pre-processing, in the sense, we want to do some of the patchwork. It is a perfect term, right? Patchwork or tinkering work to our data, so that my model can understand the data, or my model can accept the data. So this is the format why I provide, why we need to do data pre-processing. Data pre-processing is one of the crucial step in building a machine learning model, because it plays a very huge role in impacting the performance of the model. So what I'm doing, in the sense, here I am cleaning, I want to perform data pre-processing. Data pre-processing involves cleaning, reduction, transformation, and also another one thing is there: cleaning, reduction, transformation, scaling, standardization. These are the some of the methods we use. Another one is feature selection. We need to do that. So I said data pre-processing is to clean the data, and you might have the questions, that is Kritika said many times, that is cleaning, transformation, feature selection, and there are many methods: normalization, standardization, many methods are there, out of which today I'm discussing these methods, because if we discuss more, we won't have time to discuss our algorithm, so I'm going fast with that. So the first one I mentioned you is data cleaning. Data cleaning in the sense, first we want to check one thing, that is whether my data has null values or not. Null values in the sense, if my data has many empty spaces without any values, in the sense our model doesn't knows it is not a part, it doesn't have any values out there. So we want to convert every null places into one single variable. For in the sense, data cleaning in the sense, so for in the sense, I'm having that zero in one place, missing place I will be having slash, nil, and sometimes nil in different versions. Like, we need to make everything common so that it would be considered as a null variable. So we need to clean our data sets. So first, let's do this step in data pre-processing, that is data cleaning. In data cleaning, we will handle missing values and remove the duplicate values. For in the sense, if any of the rows is repeating in the sense, uh, or if any of the rows is repeating in the sense, we can delete it and remove it, which means deleting duplicates. And another one is uh, handling missing values, which means I can handle missing values. For in the sense, if my age is missing but my birth year is there, in the sense I can calculate it. So we can do it. And identifying and dealing with outliers. Outliers is in the sense unexpected error. For in the sense, age cannot be zero, right? For in the sense, these are the things we are going to do now. The first thing we are going to do is, we are going to do data cleaning. As I said, the first step in data cleaning is handling with missing values. We want to search for missing values first. Is there any missing values in my data? For that, what I'm doing in the sense, here missing value in the sense null values. So here you want to understand one thing, df in the sense data frame I have created, so using pandas, because it is stored as a custom object, so I'm creating a data frame. So I'm taking the data from the data frame. In the data frame, I'm just counting is null in the sense, is there any null variables there, and I'm just summing it up in the sense, instead of deriving and getting all this missing values and printing them, I'll get a sum of values, like how many values I'm having, how many columns is missing, how many variables is missing. I'm just going to um check it. So here df is not defined, so what we are here want to do in the sense, so here I missed one thing, that is I haven't defined df. So you can see here, I just did one thing, that is I missed the df term. Right, let's do here. And before that, we need to do another one thing, that is um, iris underscore df. So I've here given a name as iris underscore df. So I'm just getting this value to run my code. uh, because I'm not giving the name as df here, I just modified it. So now you can able to get the results. Hope you got it right. So this is a simple error, right? We did like everyone who is a pro in machine learning also makes mistakes every time, because we want to know what is the variable declared in order to be a calling. So here I used iris that underscore df as my data frame name, so I am calling that to print the values. The next one is, we can also want to see how my data set is. So like comparing how my data set is, we can do some steps, like we can find how many features targets are there. I'll say what is features and targets so that you can understand here. So let's print it. See here. So iris dataset information. So I'm getting feature name. Feature name in the sense, what are the features which is here, like sepal length, petal width, and also there is another one column, that is target, right? These are called as features, and the last one is called as target, right? In target, I have three outputs. One is which means three classified outputs. One is etosa, versicolor, and another one is virgincia. So virginica. So, and how many number of samples, which means how many rows I have, how many columns I have, right? We can also get this information using describe of function. Hope you are aware about that. So we just provide the data frame name dot describe of, it will provide the entire information about the data set. So we can try it, iris dot describe of. So here describe function is providing me error, so let's check with that. So I need to use the same data set name in order to print it. So let's get in the next step. So if you use describe function, in the sense you can get all the details as I printed in the above. So like providing the name and printing it, for example I will do here. So again I'm giving the details, that is dot describe of. So finally we got it. So again I did the same mistake, that is providing the name of the data frame iris df. I made that mistake. So here you can provide see the entire details, like what is the mean, maximum, standard deviation, value, count, everything here, right? To provide a detailed explanation about my data set, you can just inspect it and look into it. So what are the things now we did using scikit-learn? We just installed, we imported, and then we used the existing data sets there, and then we uploaded we loaded iris data set and seen and printed, and which means we provided x and y, which means predicting feature and target. And after that it was shocking to see our output is produced as custom object. Then we got the help of pandas. Using pandas, what we did in the sense, we created a data frame, and then we found is there any missing values in my data for data cleaning process. But luckily I don't have any missing values, but in real world data it is a huge lie. So we have the number of missing values, we need to handle that. So and the next one is data set information. I got some of the information from the data set, and I got describe a function to understand how my data is well described, which means how my data is there, standard deviation, mean, median, everything. So hope you got an understanding about one thing. So here you get one information from my data. Don't get confused why I'm getting this, because I'm using another one collab notebook in the next page. So my runtime is getting disconnected, so no problem, because I'm using another one data set, which means another one environment to show that. So I'm just disconnecting this, or else it will be like showing a notebook and talking about that. It never makes sense. So now first what we did in the sense, we checked for any missing values, but luckily we don't had any missing values. And the next one is we are looking for duplicate values. There is a difference between missing and duplicate, right? For in the sense, if a 162 column is not present in the 162th row is not present in this data, in the sense we can call it as missing. But duplicate in the sense the 162th column may be present multiple times, we call it as duplicate. So let's check for duplicates one. So again that's a mistake. I need to provide iris underscore df every time hereafter. So because I have changed the name, so why I did that in the sense, so that only we can understand why we are going to do that. Okay, now I'm running this code. I hope you can see that my duplicated column is 142, right? 142th column is duplicated. For printing in next row, I'm getting it is the same row, right? So for printing in next line, I got it the same thing, right? Hope you understand what I'm trying to say. So the next thing, what we did in the sense, we found it. Now what we do in the sense, we want to drop it. Hope if you're familiar in the pythons pandas, in the sense you know that dropping these values. So now I want to use iris underscore, so that only I don't get any output error. So I just dropped them after removing duplicates. After removing duplicates, we want to print it, right? So I'm printing it. So I'm getting a cleaned data set now. So here you can see my 146th column is not repeated two times. 156, right? 146. 142. Okay. it is not repeated in this one. Okay, if you print the entire thing means you can able to see that it is not repeated anymore. So I just dropped the repeating column. Hope we did this process right, cleaning the value. So for handling missing values, we just checked it using null function. Luckily I don't had anything, so that I am escaped from the situation of handling it. And the next one is detecting the duplicate values. We looked for the duplicate values using duplicate of function, and we found something. One of the column is, sorry, row is repeating, and what we do in the sense using drop function in pandas, we remove that. Hope now you can understand, right, why a scikit-learn depends on pandas, because I'm working with the data set, right? That is what hope we completed data cleaning. Next, let's see data transformation. So I said one thing, that is data pre-processing involves four: cleaning, transformation, feature selection. Another one is standardization, right? In transformation, we use methods that transformation, it involves more methods, standardization, normalization, more and more. So actually, it is three methods: cleaning, transformation, and another one is as we said, what is that? Cleaning, data transformation, and feature selection, right? Feature selection, which means selecting important features. So now I'm going to do data transformation. So data transformation means, right, transforming a data from one format to another format. Why I need to do that? Because I'm going to perform some operations, so that the data should be all the features are considered as the same thing, right? So all the features are given equal importance to provide an output, so that it should be justifiable. For in the sense, if I'm having sample length in centimeter and another one in millimeter, is that acceptable? No, right? So that we go for this method called standardization and normalization, so that what we do in the sense, we can able to do the things that is mm, we can do one thing, that is converting them, mean into zero, and standard deviation of one. Like that is what standardization means. Here I highlight you using color, so that this is what standardization means: mean of zero and standard deviation of one. So we try to we try to come with the values that is 0 and 1. You have a question, right? If I convert the mean and variance into this value, in the sense, what is the dominancy, or what is the thing I can achieve in the sense, none of the feature will dominate in the sense, if one of the thing is higher, in the sense it might result in the error, so that we are giving all the values as different one, not the similar one. Because if I change the variance value and mean value, in the sense the entire value will change, the entire value of the column will change. In iris dataset, we don't usually need it, but because if we are handling a large amount of time series data, in the sense, we can go with the standardization. So standardization is the process of by which we can convert mean to zero and standard deviation into one. Hope you got it what I'm trying to say. So I'm running quickly into that part. That is data transformation, that is standard scaling in the sense, as I mentioned you, it is standardization. It is a process by which I convert the rows into columns and columns into rows, right? Sorry, that's the error what I mentioned. So I will convert mean into 0 and variance into 1. So now let's execute it. So here I'm using a function called standard scaler, which is helping me to do the process of standardization, and it is present in sklearn.preprocessing. I'm just importing that, and what I'm transforming, in the sense, I'm not going to transform the target variable, right? I'm just going to transform the predicting variable, which means the features which help me to produce the output. I'm just going to convert it, and after that is I'm replacing the data as scaled values in the sense what output I got into the data set, and I'm printing it. Hope you understood what I'm trying to say. Standard scaling, and then I'm going to print the converted values. So let's print it. One second, I'll show you how we can print it. So we can print the, okay. So here we can print the data frame. Hope you can able to see, right? I just mistook all the functions, so I did it here. So I just printed so that here these values shows that all my rows, which means all my values are converted into the values by which it mean will be 0 and the variance will be 1. Hope you understand what I'm trying to say. That is what this thing means. The next one is feature selection. Now we discussed the standards scaling, which means standardization. We did it using standard scalar. This is the important point, that is mean 0 and standard deviation 1. Just make a note of it. Why I'm doing in the sense the features don't dominate. Uh, I'm just highlighting using yellow. So yellow is not visible to us. So I can do it using violet. So now it's visible to you. Hope that is what I'm trying to say you. That is not only we can do it. This is one of the method to do standardization. There is another method called one hot encoder is there, label encoder is there, PCA, min max scalar. There are a lot more methods there. You can use it to do standardization by which the values will get standardized. The next one is feature selection. Feature selection in the sense we will select important features to produce the output. Important features and feature selection in the sense sometimes or columns will be correlated. Maybe a reason correlation, one of my features, which means all my predicting variables are correlated in the sense my model is absolutely an error. I'm not saying model produces error. My model itself an error. So what I'm saying in the sense we not always used to take that correlated variables. Correlated in the sense one variable is born from the combination or by the little change of another variable. It results in an error of the entire model. So we do that feature selection in order to make sure that this step hasn't happened so that we can reduce the error. So we do feature selection. There are many methods there, out of which here I'm going to use a select gap best method, right? Select k best method. So I'm highlighting it here. So this is the method I'm going to use here. So it uses a function called ANOVA. You studied in math. This is an ANOVA function which is used to do principal component analysis. I hope you have studied in math. If you're strong in math, in the sense if you completed your UG or anywhere you have studied here about ANOVA, so so it will help me to get top k most relevant features. So that is what I'm trying to say is feature selection. I'm going to select non-correlated features. Why? In the sense so that only I don't get any correlation based errors. So I'm using a method called select k-best, out of which it uses a function which uses a mathematical concept called ANOVA. So it selects a top k most relevant features for me. So that is what we did here. So I'm just going fast as we are close to time. So I'm just pasting it here. Oh my god, it is not copied yet. I'm just pasting here so that so here I'm facing an error due to indentation error. So I'm just removing this. I don't get any indentation error now. So df is not defined, so I need to give iris underscore df. Iris underscore df. Same thing. Iris underscore df. But here in iris dataset we don't need to perform these steps because we only have um, not non-correlated features, right? So we don't have any correlated features. I'm just doing it for an reference, but it is not actually needed for this dataset. So I did here. So as I said, select k best. I'm just importing it, and then I'm using the ANOVA score. and top k values, which means I am giving here k equal to 2. If I define here a top k values, in the sense how many k values I want, it is manually given one. So if we give 3, in the sense it will select 3. For in the sense I'm giving here 3 here. If you get any questions in the sense, so here you can see 3 values, right? So that is the exact thing, how it works. Hope you got clear about the thing. Next thing, that is feature selection. Now it's the time to dive into algorithms. Before diving into algorithms, I want to show you another things, that is one second, I'm just going for my downloads and showing you performance metrics. So I prepared this for an easy explanation for performance metrics. So every time when we call if an algorithm is working well or if an algorithm is not working well, in the sense, we want to do some performance metrics. So there are many performance metrics we usually call accuracy. I got high 80% accuracy and all. There are many factors, like even if a model will provide good accuracy but with less precision, in the sense it is not doing good. So these are the formulas for making producing the output. So for accuracy, number of correct predictions by total number of predictions. Precision, in the sense true positive, right? True positive, false positive, true negative, and false negative. That is covariance matrix. Hope you studied there in covariance matrix of machine learning. So I'm just using TP divided by TP plus FP, and recall, in the sense TP divided by TP plus FN. So, and F1 score, that is one of my favorite formula. I don't know why it is 2 into precision into recall divided by precision plus recall. So that is a formula. And then confusion matrix, sorry, I said covariance matrix, right? Not covariance matrix, actually confusion matrix. I got confused here. So confusion matrix. So here we have all the values, like a table showing the values. And in regression, mean absolute error formula and mean squared error, as well as R squared formula. Cross validation, k fold cross validation we do, right? Splitting into k folds and evaluating them using train test split, and again splitting them to produce the output. And another one is grid search. These are the common metrics we use. As I mentioned here, it is all classification metrics, regression metrics, and the common cross validation model selection metrics. Hope you understand this. That is performance metrics of this one. Uh, that is machine learning algorithms. Hope now we are clear cut in, and we are now moving into algorithms. So into the close part.
I think we can take a few questions before that.
Okay, sure, sure. I'm just getting back. Sure.
Okay. Okay. So does standardization impact the actual data? How to generate a
Okay.
conclusion that it does not? Yeah.
So, thanks for the question, Ayush. Actually, standardization never affects the original data. The simple thing is like deriving, as you know, we take a small formula and derive a biggest formula from that. So, there is no actual impact provided to any data. But it will help us to do one thing, but is all the standardization values differ. So one of the metrics which is proven, that is using standard scalar, will help you to get the perfect output, but it never affects the actual data, in the sense, because it never affects your actual data, because you are just making the mean value 0 and variance value as 1, right? So it never affects your data, like every mathematical operations we do, it never affects.
Okay. Alternative for F classes for feature selection.
So there are many functions we can use for feature selection. There is one thing called D something. It starts with D. So we can also use for feature selection. There is another one thing called there is using underscore, like underscore feature selection is there. So there are many methods there, and also for feature selection, mostly for F class, if we know PCA, right? Principal component analysis, we just create all the features into principal components like one or two, and then we can do with PCA. And linear discriminant analysis is also one of the famous method. So why here I used F class, if in the sense I'm going to teach you PCA in the upcoming algorithm part, that is for dimensionality reduction. So I thought of going with F class if method, because it is one of the function, and Scikit-learn, so only I chosen to do F class if that is one of the motto. But mostly we prefer using principal component analysis, PCA only.
All right, then we'll take one more right now. How to choose scaling transformation methods.
Okay, you want to know one thing? Transformation in transformation method, there is two different things we want to take into account. What is our problem? The first problem is we want to reduce our data, or like we want to select whether we want to do feature selection, or else we want to do another important which means what we did for in the sense. Let me show you. One important thing is feature selection and another one is like standardization. You are asking me how we can choose between the two methods. So if you feel for in the sense, if you feel your data has uh, Chandni, hope, if you feel your data has dominant features, for in the sense if my data has more maybe virginia species in the sense, what I can do in the sense, I can go with the method which will help me to check whether to reduce dependency. That is the first method. As well as another one, standard scaler in the sense, which would help me to reduce, which means dimensionality reduction, right? It will reduce the dimension. Whether I want to reduce the dimension, here comes the question. I want to reduce the dimension or I want to reduce the dominance. The both differs for my model, right? If dominance in the sense, we mostly choose the first method. And if it is if it has many what to say, that is we want to reduce the dimension in the sense, we go with this one, Chandni. Hope you got a clear view about what I'm trying to say. That is the difference between standardization and that.
Okay, so we'll take rest of the questions at the end. Feel free to ask more questions. Continue with that.
Yes, thank you so much for all your questions. That shows that you all are very much active towards the session. I loved all your question. That is one of the question that is my most favorite question is the last question. That is you asked me. That is where I can choose standardization uh, and feature selection. I forgot the name, feature selection, right? Standardization is mostly preferred at the place where you feel there is a dominance, right? Feature selection in the sense where you want to reduce the number of features, which means you want to reduce the covariance feature, which means correlated features in the sense, you can go for that. That is a brilliant question I got. And another one that is related to which method we can choose, I haven't mentioned while I'm writing code. So PCA is the one of the most preferred method. PCA and LDA is also another one method, one hot encoding. But mostly we don't go with this one. That is this one. That is what I want to try to mention here. So select k-best is one of the method we use, and another one is there, that is like maximum voting and minimum voting is there, max vote and min vote. But we usually prefer that select k-best because it follows ANOVA rule. Hope you are clear now. So I believe now you have a bit okay. I know you are bit okay with what I'm explaining. So I'm going to have a quick recap before entering into algorithms part. So before going for algorithm parts, I'm just mentioning you once again. Scikit-learn, also called as sklearn. It is a package for doing all the. It has all the tools for performing machine learning operations. So and then I imported a data which is itself present here, and another one in the sense, I loaded the data and I found one thing, that is it is stored as a custom object, and then I can used pandas and created a data frame, and then I checked missing values using null of function, and then I described my function, which means what are the count, mean, standard and all, and I checked for duplicates. There is duplicate presented, so I just use drop function and dropped that. And then I used a standard scaler for standardization in the sense we convert mean to 0 and variance to 1. You need to know one thing here. It never, that is also one of the brilliant question, that is if I change the values in the sense, it never impact my actual data. So because it is just one of the mathematical number derived from the same number. Hope you know. For in the sense I'm saying that 2 into 3 equal to 6. I got this number by multiplying 3. That is the same thing, right? I just obtain the same number. It never impacts your actual data. That is one of a brilliant question. So, and we used a standard scalar for standardization and k-best for finding the features. This is how we did. Right. Now, we are getting into the next thing. That is, in our lecture, we are coming into the next part. That is where we can, here we are going to build the own models, which means not own models, we are using to build algorithms now. We are going to build algorithms now. So here you want to know two things. This Scikit-learn package will help me to do supervised and unsupervised machine learning, because reinforcement learning is a goal based and a reward based system. So we usually use reinforcement learning as deep learning architectures. We use deep learning algorithms to do that, and there are separate algorithms for that. We don't go with sklearn. You never get confused if anyone is asking you the question, so where you prefer sklearn, which kind of problem solving you can use sklearn, in the sense supervised learning and unsupervised learning. So we know what is machine learning, right? So machine learning is classified into three: supervised, unsupervised, and reinforcement. Hope you are clear with that. So in supervised, we have classified into two, that is regression and classification, and unsupervised as clustering, association, and dimensionality reduction. But mostly we talk clustering and association, but there is another concept called dimensionality reduction. That is also one of the major concept we use as an algorithms. There are separate algorithms for that. PCA is one of the PCA, LDA. There are many algorithms there. One of the major component is PCA. Right, dimensionality reduction comes in unsupervised machine learning. Right. Right. Let's discuss what is supervised machine learning. The supervised machine learning, in the sense we mostly say the one word, that is we use labeled data. Here we have unlabeled data. So what is the difference between labeled data and unlabeled data? Here comes a question. So for the concept, that is regression or classification, in the sense I have a set of data, which means I have input and output as a set of data. If I provide new input, in the sense my machine needs to make prediction. That's it. Prediction or classification. That is what regression is, right? If I provide a new data, in the sense my machine wants to make a prediction, right? That is what regression means. In supervised machine learning, we do prediction and classification. So prediction, as I said, if you provide new data, it needs to produce an output. As well as in classification, in the sense, so we are classifying based on labels. Here we have an labels and proper reason for why we got that. So this is how we do classifications, right? So basically the same thing. Supervised machine learning uses labeled data. Labeled data means we have a target label. Target variables have a label. As well as unsupervised, in the sense we don't have any one separate column first of all as a target, right? We don't have anything. We just classify the input variable. That's it, right? We have target variable, everything only in this supervised, right? The target variable, these things and all, we don't do on there. That is unsupervised, right? Hope you are clear here. So let us start with supervised machine learning. So supervised machine learning start with the first concept, that is I did what thing first, classification of the iris dataset using SVM algorithm. So support vector machine algorithm. I know most of you are aware about support vector machines. In support vector machines, let's say my hand, right? This is x-axis and y-axis. In the sense, I try to draw two lines, right? Two boundary lines for my data, so that the both columns never merge, like drawing a margin line between them. It is one of the best method to make two class classification or multi-class classification. It works very well. So we prefer support vector machine, right? Support vector machine, in the sense we use support vectors as well as margin value and boundaries to make a prediction. If you go for Google, in the sense, let me Google you and see what is SVM. In the sense, let's go for images. So this is one of the perfect image. I'm just making a Google search to make you help you explain the concept, because I don't have an image with me. So let's take this image. So here you can see this is one class and another, this is another one class. So This is the margin line, which means maximum margin. It is trying to split into two classes. So here I have positive hyperplane and negative hyperplane. This hyperplane is drawn based on the data point, the last data point touching, right? The last data point, we will draw this line. So these data points are called support vectors. This is the concept of SVM. Actually, SVM works very well for two class classification. So it is proven in research too. If you are working with any algorithms, in the sense, you can, if you are trying for two class classification, in the sense, you can always prefer SVM. It provides the best output when we compare to others. So let's go for coding. So here I'm just getting the code into my page so that I can explain you much way better. So So here you can see that Scikit-learn import dataset. As you know, I imported the dataset, which is load underscore iris. These steps I have performed you previously so that you can understand what is x and y. Uh, and then what we did, in the sense, I did another one thing, that is using model selection. In the model selection is the function which is used to select a model. I think I'm introducing the term to you now, model selection, in the sense. So it helps me to select various models, because there are many machine learning models present here. I'm going to select that. And train underscore test underscore split, every time we split our data into train and test set, because we need to also equally train our model and also test it to know whether my model is performing well or not. I want to provide equal amount of data for training, as well as I want to do ample amount of testing, right? I want to split my data set into training and test. And after that, metrics. So sklearn metrics, in the sense, we have seen here, right? Different metrics. So these are the metrics we used to do here. So I just checking with sklearn metrics. Here I'm using classification report and accuracy score. So classification report, in the sense, it will produce all the classification results. I'll show you in the downside. And the next one is, let's take iris x y. So here the y prediction, in the sense, the predicted value is from x test. So just know this. For, in the sense, if it is a data set, in the sense, I'm going to hide this y value, and I'll be giving x test case, which means these values will try to predict this. So based on the relevancy to my actual result, I will make the accuracy, which means I will make that whether my model performed well or not. That is the concept, right? So I'm just doing that. And now let's run it, like classification result, everything. I'm just running it. So CLF is not defined. Let me know where I made this error. CLF dot predict of. So here I did a mistake, that is I removed this line. CLF where I, one second, just copying it again and pasting it again, because I eventually deleted the line. Invalid character. I'm getting an invalid character. That is due to CLF dot fit and everything. Okay, let me run this code here, because I'm getting an error. So because the reason is, it is not getting copied for me here after x and y. So these two lines to get copied for me. So I'm just getting copied and pasting over here. Yes, I did it successfully. So I'm removing this line now. Yes. Sorry for that, because I was facing some issue in my keyboard. That is the reason. I'm just using my mouse now. Okay. See here, I'm explaining the code again, once again for you. So here, what I'm doing in the sense, I'm selecting model from selection, I'm selecting train underscore test underscore split. It is used to split my data, as you know, into train test. Mostly we prefer 70/30 and 80/20 ratio. 80 is for training, test. It is one of the proven ratio that model will perform well, has an ample amount of data to train as well as test. So that is what we usually prefer. So here I did it. Here you see, here test size is 0.2, which means 20 percentage, which means already my training percentage will be 80, right? So I did it here like 80/20. Random state is equal to 42 in the sense, we mostly, you have came across this value, right? Random state equal to 42. Why I'm providing this value 42 in the sense, here the train test, I'm preferring that the train and test will not happening in a row wise or column wise, which means the first topmost rows will be given for training and the last most row will be given for testing. That is not an ideal method we want to follow, right? So I'm just giving a random number so that it will start from there. So random state equal to 42 in the sense, it will start from that random number. So that is what the reason of giving 42. But mostly, like giving pandas a name PD, allies name as PD, it is universally accepted. Like this 42 is universally accepted by us, so you can give any values. And then I'm loading the data, and then here you provide the kernel values as RBF. So you know, the kernel values means we'll be providing the border lines, which means a margin and different things, right? So that is what SVM classifier I'm giving RPF, as well as and the next one is like I'm trying to fit it. After fitting my classifier to my data, I'm making the prediction. So my prediction will be like the values what I got. And next one is I'm printing my report and accuracy. That's it. Printing my report in the sense, as I showed you in a PDF, precision, recall, FN score, and support values. So it is printing that, and accuracy is 100, because here the data is so low, right? 150 rows only, so that the model easily memorize it. I can say it is a memorization error. The model tried to memorize the results. So I'm getting 100%, but it is not possible to get 100% as accuracy for real world data and all, which means we made error somewhere. But here the data set is too less, so that it is fed with less amount of data, so we are getting this output. So that is what SVM is about. I hope you can understand what I am trying to explain you now about SVM. Hope you are clear with what is SVM. I hope you are aware about SVM previously because you are studying machine learning. So what I'm trying to say is, I'm using function from Scikit-learn, because this session about Scikit-learn. Here, see, I'm importing data sets from here. Model, which means train underscore test underscore split function is present here, and my model is presenting here, and all my metrics is presented here. This is why I'm preferring that. Hope you understand what I am deducing SVM. So when we talk about this value, that is classification, in the sense there are many algorithms present here, that is decision tree, random forest, classification, and also logistic regression. Most of the people think that that logistic regression is one of the regression based algorithm, but not actually. Logistic regression is a classification algorithm. You want to know that. um, and I want to mention you another thing, that is RBF. I haven't provided you definition for RBF. So here the mapping in, that SVM uses high dimensional space to represent data. So I'm drawing a hyperplane in a hyperplane in the high dimensional data. So we use radial basis function, that help us to plot that, which is a function, right? There are many functions preferred, but we mostly use RBF, right? uh, Actually, there are two different kernel we can prefer here. One is RBF and another one is polynomial, right? RBF and polynomial. So this would help me to know that which one we can prefer. Okay, hope you understand what I'm trying to say. RBF and another one is there, that is polynomial. We mostly prefer RBF because it provides the best results as compared to polynomial. Polynomial, in the sense, it is preferred to provide 3 class or 4 class classification. Here I'm just doing 2 class classification, right? So I'm not preferring that. So a polynomial, right? That is the reason, that is RBF. RBF, in the sense, a radial basis function. It is also a mathematical approach, right? Hope you're clear with SVM. I hope. I wish to know whether you all are clear with SVM or not. Um, I'm very much interested to know if you have any questions related to SVM so that we can skip into next part.
Okay, we have a few questions right now.
Yeah.
What does random state
Yes.
does in train test splitting?
Yeah, mentioned, Ashish, as I mentioned you, random state help us to which is the starting position for my split, right? Right, my algorithm is asking me the question where I start my splitting. So if you give zero, in the sense it will start from the first. Like every time, like the first 80% will be given for training and testing. Here the random split value gives you to give where I want to start my splitting. Mostly we provide 42 so that it is like we are giving allies name as PD for pandas and and more like matplotlib we give it as MP, cborn as SN, and there are many things, right? SNS for cborn. Likewise, random state is your choice, like where your model want to start splitting.
All right.
How to
How to increase
increase
the score?
specifically F1. So as I mentioned you, if we want to improve the performance of the model, in the sense, what are the steps we can do? We cannot particularly improve F1 score. So if we want to working on improving our model, in the sense, if mostly we prefer precision, if we have good precision and accuracy, in the sense, of course the F1 score will be good. So if we want to improve the performance of the model, in the sense, you can do hyperparameter tuning, and also sometimes dimensionality reduction and proper data pre-processing methods, uh, and and evaluating whether the data has a correlation, which means whether our input features has any relationship correlationship between them. That would help us to find whether there is a relationship or not. So I would say you that if you want to improve F1 score, in the sense, you can adjust the F1 score, sorry, adjust the hyperparameters, hyperparameters in the sense the train test split or random state or anything else. You want to adjust that values, and you want to look into that correlation. That would help you to improve the performance. And also you want to make sure your data has underfitting and overfitting issues. If you have overfitting or underfitting, you want to just find that and you want to avoid that. So if you avoid underfitting and overfitting, in the sense, mostly you don't get any issues. Ashes.
Okay, then we have this.
Using a standard scaler, why do we scale it to mean zero and standard deviation one? So it is a good question. So it is one of the theses in mathematics that proved that while we want to standardize a variable, if a mean is zero and the standardization is one, the value never change, which means it never affect the input data, which means you can always pair to input data much easier. So like having mean zero and standard deviation, well, that is the reason I don't want to impact my input data. That is why I'm using this rule. If you change it to standard deviation zero and mean one, in the sense, it absolutely affect your data, which means you'll be getting different output for your actual input as well as changed input. So that is the reason. Krupi, that is the reason.
Okay, we'll take one last one.
Okay. So, which method is best to find outliers in machine learning? As I mentioned you and highlighted here, for finding outliers, let me show you. So, to find outliers, we mostly use these methods. So, for in the sense, see here, I'll show you. So for removing outliers, one of the common method we use is there is a function in Python that is used to avoid E-based errors, like mostly invalid character error. There is a function there to avoid that. If you want to deal with outliers more, in the sense, so if you are having more outliers, means you will be having overfitting and underfitting issues with your model, so that you want to work with that. So we want to check whether our model is learning, memorizing the content, or else it is getting a confused result. You want to look into that. So mostly to deal with outliers, we usually go for data pre-processing, working with well pre-processed data. That is the one I forget to mention here. That is the thing we want to work with, more data.
Okay, that's it for now. We'll take the rest at the end.
Okay, sure. I'll be continuing with the next part, that is, now we completed classification. Next, let's get into the look of next algorithm and we'll get some questions so that it'll be cleared at the moment when you got the questions. The next one is linear regression. So, you know, I mentioned a term here. So, linear regression, first, let me give you an explanation about linear regression. Uh, Linear regression is only performed between the variable which has a continuous relationship. Here continuous in the sense, if my x increases, in the sense y also increases. There is a direct or inverse relationship between both variables. If it is present, we can go for regression. For in the sense, if square feet rate increases, or if in the sense, the square feet of my room increases, in the sense the price will also increases. That is a concept we use for linear regression. But here, iris data set, we have classification variables, right? Here we don't have a target variable as numbers, but unfortunately we here have it as a what to say, that is as categorical variables. So we go with this stuff, that is regression. We are using another one data set, that is California housing data set. Hope you came about the housing data set. It is same as housing data set. So I'm using that data set to make a prediction. So I'm just pasting it here. So same here. 1 minute, I'm just adding all my previous lines so that I don't get any errors. Okay. See here, the same thing as we did it on the previous thing. So here there is a difference. You want to make sure in sklearn dot linear underscore model, I have linear regression, as well as in classification, I used directly SVM. I took SVM. But you want to know that linear regression belongs to the linear model family. So it is one of the member of that family. So we pick from linear underscore model. And then, here, for this one, we have many functions for evaluation, like mean absolute error and mean squared error, and also r squared score, everything, right? So here I'm preferring mean squared error and r2 score as to evaluate my performance. So here, in the sense, I'm just loading my data. So here you might get a question, why Kritika is giving fetch. Fetch is also a function we can use to fetch our data. So to give a difference, like instead of using the same function every time, we can use fetch function also to fetch the data. And I have provided me with x and y, which means target variable as well as predicting variable. I have splitted here, that is test size as zero point 0.2, random state as anything. Right here I'm giving 0. Right, it never impacts anywhere. And another one is, I'm just uh, building my model, that is linear regression of function, and then fitting my model, fitting the data into my model. So that here I just fitted my value x train and y train, and then I'm predicting the value of x test, which means I'm giving x test as a input, and I'm trying to get a y prediction as output, so that I can make prediction. And after that, I use this method. That is, there is a function here. We don't know either to write formulas here. We just call our function like mean underscore square underscore error, as well as r2 score, to produce our output. Let me print here. So see here, see, I don't got any errors. The reason is I just got 0.5 percentage of error, which means my model is having a less amount of error because it is close to 0.5, which is close to 0. And r squared error is also good. So how we can evaluate between this error is r squared should be high, as well as mean squared should be low. So what I see here is my linear regression model doesn't fit very well to this function, right? So I need to do some other process, like going with so let us change the random state into 42 and see the difference. See here, there is a difference, right? 55 and 57. So it is like a manually provided input, right? If you adjust the random state values, there is some difference. So that is what I mentioned you, right? So it is your choice. Like, they are hyperparameters. If you adjust, you will get a good performance in your models, right? That is what I said you. So that is about linear regression part. This is how you build a regression model, right? Hope you clear now. I'm just giving you here 32. It produces output. So someone asked me this question, why always random state is 42 at 0? You can give me anything. See here, my performance is getting affected, right? So that giving an ample right amount of random state might impact my performance. So that is the reason mathematically it is proven 42 and 0 works better. You can always give any values to improve the performance of the model. You can see here I'm getting R score as 57, right? This is the difference here. So that never affects your anything, right? Hope you understand what I'm trying to say in this linear regression function. This is not that much difficult, you think, but only one difference is I chose linear regression from linear underscore model, and another one is like I have given random state into random values and we tested things, and we used mean squared error as well as R squared. I showed you on PDF, right? There I showed you that is for classification, there is different metrics for evaluation, as well as for regression, there is various metrics for evaluation. For clustering, there is two scores, that is like Kali's index is there, and another one is a Silout score is there. So this metrics change, keep changing, right? We want to know which metrics we want to prefer for according to the problem. Hope you understand what I'm trying to say, right? So let's get into the question part of linear regression. If you have something, just add your questions so that I can able to see your questions. I guess we can keep linear. Okay,
We have
this is
two previous questions.
so okay. It is the last part I try to explain. I'll be giving a wrap. I'll be giving a wrap. Shivaya, after that, do we have a question part? I'm
We
in.
just have two questions left right now.
Okay,
Can we cover them right now?
yeah, sure.
Alright.
How to perform cross validation and why it is an important step in model evaluation, right? Why we want to perform cross validation in this sense, it will help you to find whether your model output is true positive, true negative, false positive, or false negative, so that it will clearly shows how well your model performed. If in terms for classification, it never works for regression kind of algorithms, it works best for classification thing. So it shows how well the classification happened much easier. So that is why cross validation is preferred, and most of the metrics is based on that. That is true positive divided by true positive plus false negative. Most of the thing is based on that for classification, to know how well the classification occurred. Harun, can we use this for segmentation, like customer bank segmentation? Of course, we can. Which one you are meaning? Are you mentioning regression or this one, Aditya?
This is from the beginning of the session.
Can we use this for segmentation like customer bank? Okay, you are meaning for I think for segmentation. I hope segmentation can be sklearn. I hope you are mentioning this question towards sklearn. Of course, I need to say you something in application part. As we discussed everything of this, I'm going towards the closing end. That is because so see here, we can use it for prediction recommendations, for recommendations. In the sense, we can prefer that. Mostly Scikit-learn helps us in doing that too, Aditya. Yes, we can able to do that. Information about the mean and variation is conveyed between train and trace. It is my understanding that scaling prior to. Yes, that is true. I was just showing you. Yes, it is true. That is absolutely true. As I was explaining you about data pre-processing methods, right? What are the methods we can use? But we don't usually perform it before train and test splitting. Hope you've seen here, right? I was writing the step from starting, right? For each algorithm. See here, for each algorithm, we written from start. Even you see for support vector machine also, I haven't did use any steps prior. I just used it from the beginning. I write the code from the beginning because we don't want to do it prior to train test split, because we first want to see the performance. After that only we need to do. So I'm looking forward for another questions if possible. Share me. So I'll be coming.
That's it for the questions. Can you
Okay.
share the collab link?
Yeah, sure. I will share my collab link as well as LinkedIn. One second. Do I stop sharing my screen? Is that fine for you?
Yeah.
Okay. I'll share my collab link so that it will help them to do process well. So one second. I'm in the process of sharing. So I'm sharing via chat. Hope you received it. How does multimodal learning integrate information from different modalities to improve model performance? So the thing is, when you refer to multimodal things in the sense, it is just a data fed to model. So we use different pre-processing kind of things, even if we will Gen AI applications and all. So there is different pre-processing techniques which is provided to that. So even a model works better with multimodality. That is why the reason behind it.
All right, I think that's it for the
So
questions. I shared the collab link. Yeah.
okay. Thank you for this opportunity, Shvaya, and thanks for everyone for listening today and asking actively all the questions. I was very much happy that everyone was engaging. So feel free to connect with me in LinkedIn if you have any questions, or if you have any further questions related to my collab notebook. Just feel free to email me. I'm just sharing my email. So if you have any questions related to machine learning or something I haven't covered here due to time constraint, so you can ask me. I'm always active in email. Thank you. Thank you,
And before
everyone.
we wrap up, do you have any closing thoughts or additional advice for our participants?
So if you are the one who starts fresh with machine learning, only one thing is key, that is keep practicing. Even you can see me, I work with machine learning for about 3 years, and I have framed three new algorithms, but still I'm making an error. You have seen there, right? I'm using the name. I was making an error in making always defining a name. So I want to share you one thing, that is keep practicing. Practicing is a key in machine learning. Anyone can be an expert here. Practicing is the key.
Right. Thank you once again for sharing your knowledge and experience with us. Your contributions have made this session incredibly valuable.
Thank you.
Thank you.